Okay, welcome to our second video in calculus, 2.1.2, non-existent limits. I don't think this should take too long. Hopefully it'll be short and sweet. So we talked about this a little bit on our last video, just kind of hinted on it. This question is asking, does the limit as x approaches 0 of f of x exist? Why or why not? And this particular limit does not exist because, as you can see, when we approach 0, this spot right here, when we approach it from the left side, I'm going towards this hole, which is at -2. But when I approach it from the right side, I'm going towards this hole, which is at 1. It's not approaching the same number from the left and the right. When that happens, we say the limit does not exist. Sure, it exists from just the right side, and sure, it exists from just the left side, but the limit as a whole doesn't exist. So unless they specify from the right side or from the left side up here, you just say does not exist. So we're going to run through a few examples like that, but basically that is the whole crux of today's lesson. So, lesson. The limit only exists if you approach the same value from the left and from the right. We'll run through some quick examples and we'll be done. This one, several things you should recognize. F of 1 says, what's the value of f at 1? Well, here's 1. If I plug a 1 in, I land right there, which has a value of 1. This is a limit of f of x as x approaches 1 from the left. So from the left-hand side, as I get closer and closer to that 1, this function is getting closer and closer to that hole, which happens to have a value of 0. So that one's equal to 0. From the right, same thing. So as I travel along this function from the right-hand side, getting closer and closer to that limit right here where that box is, I get closer and closer to this point right here, which has a value of 1. And then last but not least, kind of what today's assignment is going to be about, it says, what is the limit as x approaches 1 of f of x? And for this particular answer, this answer is going to be does not exist, or D and E for does not exist. It doesn't exist because from the left side, I'm going towards 0. From the right side, I'm going towards 1. Those are not the same number, so it doesn't exist. Easy as that. If you feel you got it, you can skip this example, skip ahead to the next one. If you feel you want one more, let's do it again with 2. F of 2. F of 2 means plugging 2 in. Here's a 1, here's a 2. So when I plug something in here, I'm looking at everything there. When I plug it in, I land at that point right here, which has a value at 2. So that f of 2 is equal to 2. From the left side, as I travel along here from the left, I get closer and closer to that hole, which is a value of 1. So that's 1. From the right side, as I get closer and closer from the right side, I approach that same hole, which has a value of 1. You'll notice I'm approaching the same hole from both the left and the right. So the limit as x approaches 2 does exist because it agrees from the left and the right. It's 1. Same as these two because the limit from the left side and the limit from the right side agreed. All there is to it. All right, same type of thing, just in a different format. I didn't give you a graph. I gave you what's known as a piecewise function. This is f of x. It looks like 2x plus 1 whenever x is less than 3. And then at 3, it suddenly changes into x squared. So when x is greater than or equal to 3, it looks like x squared. So let's do each of these ones. F of 3 means you plug 3 in. Well, 3 is greater than or equal to 3. So I'm going to use this equation. If I plug 3 into there, 3 squared is equal to 9. So f of 3 is just 9. Now let's talk about limits. Limit as I approach from the left side. Well, from the left side, that's before I was equal to 3. So from the left side, I'm going to use this equation. If I plug a 3 into that, which is fine, it's a constant. It's 2 times 3 plus 1. That's 6 plus 1, that's 7. So from the left side, I'm going towards 7. From the right side, well, then I would read this graph here from the right. So I'll plug the 3 in, 3 squared again, that's 9. And then it's asking if the limit exists as x approaches 3, and I would say no, the limit does not exist. Because from the left side, the limit was 7. From the right side, the limit was 9. That's not the same number, so the limits don't exist. All right, if you ever get stuck and you're not sure about questions like piecewise functions, you can always sketch the piecewise function. That's something we did in pre-calc before, hopefully you remember. It's just sketching this thing up until 3, 1, 2, 3, right? Because then it changes to that thing. So 2x plus 1, that's got a y-intercept of 1, goes up 2 over 1, up 2 over 1, up 2 over 1. Gonna look something like that. X squared, we know what that looks. So it looks like x squared, though, is starting at 3 is going to be 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. It's going to actually start right there. 4 squared, 16, and then 25, and it's going to go like that. Right? So we can see that it's definitely not, there's definitely that break there. So it's the limit's not going to exist. I'm approaching different values from the left and the right. If you like to sketch it, go for it. Otherwise, don't worry about it. That's it. Some problems like that. Good luck. As always, feel free to stop by my office hour. I'd love to help you.